we need to reduce this matrix to the normal format, that is the matrix containing the submatrices, that is the identity matrix and then the 0 submatrices, and also we need to determine the rank then. Okay, let's start with the solution. So this is your given matrix and we need to change this matrix to the normal format. To get the matrix into the normal format, either we need to get 2 by 2 identity matrix, or we can also get 3 by 3 identity matrix, or we can also may reach to 4 by 4 identity matrix. We try to make the identity matrix of the highest order. I'm already having one over here. So to get the identity matrix, I need to make this 4 to be 0. That is, the entries below this entry 1 should be 0, right? Okay, for that, just multiply the row 1 with negative 4 and adding its elements to the row 2. So I'm going to change the row 2. So the row 2 is changed into 0, 5, negative 8, negative 10, and writing the rest of the rows as it is. I'm having all the entries to be 0 below this one. And then in the second column, I'm having 1 over here, right? I need to get this one in place of 5. For that, what I need to do, just interchange the row 2 with row 4. So interchanging the row 2 with row 4. So I'm having now 1 over here. In the next step, I need to get all these to be 0. The entries above and below 1 to be 0, right? Okay, for that, what I need to do, to get 0 in place of negative 1, multiplying the elements of the second row with 1 and adding its elements to the row 1. To get 0 in place of 3, just multiply the row 2 with negative 3 and adding its elements to the row 3rd. To get 0 in place of 5, again multiply the row 2 with negative 5 and adding its elements to the last row. On applying the operations, it's very good to have 1 to be as your leading entry. So we are getting a very nice pattern of the identity matrix, but still there is a little more work to do. Okay, I'm having negative 20 over here. It is very easy to get 0 in place of negative 20 by making the use of third row. Just multiply the row 3rd with 10 and adding its elements to the 4th row. So I need to change the row 4th by adding its elements to the row 3rd, but row 3rd should be first multiplied with 10. So what we are getting? So 4th row is changed into 0, 0, negative 8 and 0. And now to replace this negative 2 with 1, what I need to do, just multiply the elements of the 3rd row with minus 1/2, and to get 1 in place of negative 8, just multiply the elements of the row 4th with minus 1 by 8. So changing the row 3rd and 4th. So I'm getting for the row 3 0, 0, 0, 1 and for the row 4 0, 0, 1, 0. Hope so we are getting the identity matrix of order 4. Yes? I need to get 0 in place of 2. For that, just make use of the last row. Multiply the elements of the last row with negative 2 and adding its elements to the first row. So for the row 1, we are getting now 1, 0, 0, negative 1. And writing the rest of the rows as it is. Let's make use of this third row and get all these entries to be 0. To get 0 in place of negative 1, just multiply the elements of the row 3 with 1 and adding its elements to the first row. And to get 0 in place of 2, again multiply the elements of the row 3rd with negative 2 and adding its elements to the row 2. So applying these two operations together, so row 1 is changed into 1, 0, 0, 0 and row 2 is changed into 0, 1, 0, 0. Writing the third row as it is and the fourth row as it is. So to get 4 by 4 identity matrix, I just need to get 1 in place of 0 and 0 in place of 1. And also I need to make this 0 to be as 1 and this 1 to be as 0. For that, just interchange the row 3 and the row 4. Writing the first and the second row as it is. So now third row is interchanged with the fourth row, that is 0, 0, 1, 0. And fourth row is interchanged with the third row. So this is our identity matrix of order 4. And having these 4 non-zero rows, so the rank of identity matrix is 4. Hence, rank of A is equal to the rank of identity matrix, that is equal to 4. So the rank of required matrix is 4. Alright, thank you. Stay blessed.